Hi, I'm Joe Baldiga. I'm a National CNC Education Program Manager with FANUC America. FANUC's the world's largest supplier of industrial automation, CNC, robotics, and we're here in the education booth. So FANUC really wants to partner with educators. So we work with high schools, community colleges, universities, nonprofit, workforce development programs to train and certify the next generation of manufacturing talent. A lot of times robots get a bad reputation that they take jobs, which is untrue. Robots are just a technology that really multiplies the force and the strengths of humans. So we need to use our minds, our creativity, and technology to compete into the future. One of my favorite quotes is, "Your ability to learn faster than your competition is your only sustainable competitive advantage." And we're out there, we're competing in manufacturing, we're competing for jobs, we're competing for a new product, we're competing in the marketplace. And we need to make sure that students have all the right advantages and tools to allow them to compete into the future. So with our program, we train the instructor, we certify the students so that they can go out and get high-paying careers, not jobs that are dirty, dangerous, difficult, and dull. The 4Ds, those are the type of jobs that robots should be doing. We're trying to be more human-centric. We're trying to elevate people through training and workforce development, and that's what we do at FANUC. We're partnered with over 1,700 schools, training them in robot operations, collaborative robots, handling tool, advanced programming, vision systems, CNC machining, turning applications, 5-axis machining, robots on autonomous mobile platforms. One of the competitions that we're showing here is actually behind me at Skills USA, a partner in vocational training, Champions at Work. So we have some students that are demonstrating a competition where they'll get a FANUC robot, a PLC, a conveyor belt, a light stack, and students compete to wire and program and troubleshoot that technology. But these are the type of skills that they're learning that are job ready. They can hit the factory floor from the ground up and start working. So it's a great opportunity for these students to compete. They're competing in a game, but it's really training them for the real world. Products we're showcasing here at in the education booth is our CRX Collaborative Robot series. The Collaborative Robot is a purpose-built robot with built-in force sensors, so the robot can, if it makes contact with humans, it'll stop. It's speed and force limited, but it's a great way to introduce students to robotics using a very user-friendly interface. This robot can be simply programmed by jogging the robot by hand. I can manually move the robot to a location and then just simply drag an icon up onto the programming screen, just like moving an app on your cell phone. And then when you're done and you want to run the program, you just hit play and the robot will go through all of the postures that you taught the robot. So very intuitive, very easy method of introducing students, or if you're an industry customer that is maybe apprehensive about getting a robot, this is a very easy method to get started with robotics, and then you can build from that. One thing that's unique about FANUC collaborative robots, we call them industrial collaborative robots, because this robot is IP67 rated, so it's not going to get a lot of water or dust, or if it is in a dirty environment, it's very robust. You're going to get all that reliability that you can expect out of FANUC products. So it's not a scaled down, cheap, low cost plastic servo motor robot. It's a very robust. You'll get a long lifespan out of it, and it has all the advanced capabilities of other industrial robots. You can add camera sensors, force sensors. You can implement AI technology into these robots as well. So a great introduction, not just for academia, but if you're a manufacturer that's just looking to get started with robots, this is a great starter robot. So the next item we're showing here is an integrated solution using an autonomous mobile platform, so an AMR, autonomous mobile robot. So we work with a partner that is called De Facto Robotics, and they have an autonomous platform that they can install a robot onto. So this gives the robot mobility. It can autonomously move and navigate around a plant floor. This robot pairs really well with CNC machines to load and unload parts, but it could take the finished parts over to a packaging area or to a quality checkpoint, and gives that robot mobility in a larger working range. As we move down further, we see, which is kind of our standard certified education robot training cart, using the LR-Mate series style of robot. So this is a common system that we offer to educational institutes. We have our industrial eye pendant, and we train students on how to operate and program the robot. At first, this can be pretty intimidating for when you see it, but it's just like getting used to any other new piece of technology. A few minutes of someone explaining how to operate the robot, move the robot, you can become proficient very quickly. So don't let that be a fear factor of looking at it going, oh, this is pretty high tech and challenging. It's not. It's actually quite easy. Other areas, so after they learn some robot programming, how to teach code to the robot, then we want to try to integrate peripheral devices, because a robot is just one component of an automated system. So we have a conveyor system that students can integrate and have the robot communicate to that conveyor belt, place parts on. We could add a vision system where it's tracking parts. We have a CNC training simulator, so students can teach integration for machine tending, so the handshaking or communication between a CNC machine and a robot. So that's a very common application in industry, where a robot will go in and grab a finished product, pull that out of the machine, and then load in a raw blank. You know, it's a way to stay productive even over the weekend, do lights out manufacturing. As we move down, A3 does a great job of supporting education. We have a bunch of education partners from FANUC, some of those 1,700 schools I was talking about. We had the A3 Next Gen Theater, where there was a variety of presentations on workforce development, artificial intelligence, diversity in the workforce, and how to attract more people into this career field. Another thing that we did was set up a competition here within the competition area, where we invited a lot of students to come in, and we partnered with Skills USA, and we have students coming in doing a competition where they're wiring up some industrial robots. We have a variety of manufacturers that are working in this space, but we wanted to make sure students are getting trained on real technology. So now we're going to talk to my friend Keegan here with Barron Advanced Manufacturing. He's a high school student that is competing in the Skills USA demonstration using a FANUC robot and doing robot and system integration. So Keegan, can you tell me about, like, a little? I kind of introduced that you're a high school student, but how long have you been working with robotics and in FANUC content?
So I've been working with FANUC robots for, I want to say, 2 years now.
Okay.
Pretty much on the dot. I started working with them at the very end of my sophomore year, and I've reached the end of my junior year now. So that's pretty much a whole school year, but a lot of time outside the class also, and a little bit before in my freshman year as well. So I would say about 2 years total experience.
Okay, now is yours, your program, is it part of a vocational center that like a bunch of feeder schools go to, or is it dedicated like in your high school, or how does your school have a robot?
So the program is actually part of the high school. It's fully integrated with the curriculum, but not every high schooler chooses to take the curriculum. So it functions as a class and an extracurricular. So we're a unique program. Basically, the way it works is as a high school student, you can choose to be involved with the program. And if you do that, you have 3 years worth of classes plus one elective you can take. And it constitutes as a pathway. So in Indiana, the school system requires each student to have a pathway. So this is a manufacturing pathway, which basically means that it helps align your curriculum for what you're preparing to do after high school. So we're not specifically or exclusively a vocational school. We're a public school, but this is a significant program that we have within the school.
All right, and so in addition to the robots, you know, you got the FANUC robot. What other type of technologies are you learning in your classroom?
I want to say we have about 7 or 8 FANUC robots. We have a lot of these little LR mates, then we have a bigger one. We also have a UR cobot, and we have a FANUC cobot. So we've got a lot of robots, obviously. We also have a LaVille CNC lathe and a CNC mill. We have controls cabinets, so we practice industrial electrical wiring on breadboards and transformers and other electrical components, as well as we have a laser engraver, a Keegan laser. So we have a lot of cool tech in the classroom, and all of it's relevant to local industry and things like that.
And so with what are your kind of with taking this classes, do you see yourself going into manufacturing and this being a potential career pathway for you?
Absolutely. I mean, I'm taking this class because
you know, I joined the program with the desire of figuring out what I wanted to do out of high school. And because of this program, I now know what that is, and it's robots. So I never would have even touched a FANUC if I hadn't gotten involved with the program. It's unlocked so many opportunities for me, and it's just given me so many cool chances to do things that I never would have touched otherwise, just like this. And it's all relevant experience that we get in the classroom, and we also go out and tour local facilities, and all that is just stuff that you don't have access to any other way.
Yeah, that's great. Awesome. Well, thank you. So Keegan, for the folks that are viewing this, to understand what's happening with this competition, can you kind of describe what you're doing? I see some blocks. I see like a chute, a stack light, a robot. What is all this?
Yeah, so what we're working on here is it's a exhibition contest. So at the 𝐄𝐦𝐩𝐴 competition, we're given a task on paper that basically is meant to simulate an industry task and something that you would have this robot doing. So our goal is to set up the work cell here and program the robot to perform that task as efficiently as possible. So what's happening is we have this gravity parts feeder. So these cube parts come down the parts feeder, and the robot picks from the parts feeder and then checks each side to determine if there's a hole using these limit switches here. And all of that we set up and wired out and wired up. You can see what we've taped here. And then we have all our inputs and outputs wired over here behind the robot. So the robot picks the part and then checks each face of the part to determine if there's a hole. And if a hole is present, it will then go to this prox sensor here and detect material type. And it will sort over here into this contraption, this 3D printed parts holder based on metal or plastic.
Awesome. So this, it looks like you're doing some hard wiring. Have you, outside of the competition, have you ever worked with like a PLC, programmable logic controller, and done any setups like that yet?
Yeah, absolutely. So we actually didn't have this particular brand of PLC, but we have a lot of Allen Bradley PLCs in the classroom. So we work with programming PLCs as well as a lot of industrial electrical that includes hard wiring, inputs and outputs, and things like that as well.
Okay, and so I see you're doing pretty proficient on the teach pendant as a mechanism for programming. Have you done any work with FANUC simulation software or RoboGuide?
Yes, I have worked with RoboGuide. Actually, through 𝐄𝐦𝐻𝐴, which our program competes in, I had the opportunity to go to nationals, and I was actually able to get certified applied robot operator with the RoboGuide. So we mess with the RoboGuide software a lot in class as well as the physical robots.
Okay, so you got your 𝐸𝐸 credential. That's awesome.
I did, yeah.
So 𝐸𝐸 is the National Occupancy Credentialing Testing Institute. So they're a third-party assessment test that students can go through. So after they've learned robots and robot integration, RoboGuide, they can sit for this test as either a knowledge-based test and applied. So he has a full certification. So he's bona fide accredited as a FANUC robot operator and programmer and familiar with RoboGuide simulation software. And how old are you again?
I'm 17 and a half.
17 and a half. So look, this kid has a bright future, absolutely.